Okay, welcome everyone to the second round of talks. You chose the right room. I have the honor to introduce to you our speaker right now and what he's going to talk about. So, in front of you stands Stefan Keller. He's a full professor at OST Rapperswil, which you might also know as HSR. They changed their name. And there he's been teaching database systems, data analytics, and geoinformation systems for over 20 years. And he's been the director of the Institute of Software for almost just as long. Today, Stefan will show us some surprising applications of SQL, as well as help us choose the correct database system for whatever project we are working on. Good, so give it up for Stefan, and let's have a good talk.
Thank you very much. Thank you. I'm having a tough competition actually, because at the other side there's metaverse, and I will talk about hypes and things as well. And thank you for the introduction. And let's go. My goal of the talk is giving tips on choosing a database system for your next project as a data or software engineer. Another goal is to clear up some hypes and misconceptions about databases, and the final goal is to provide some examples of SQL you probably did not know before. Actually, this is a challenge for me myself, this talk, because the speakers are told to talk about something students don't hear in the lectures. So that was a tough challenge, because I'm used to tell basic things and facts and things like this, and they should be taught. But so the goal is to teach something out of the usual curriculum. And in fact, choosing the right database is something students told to me. Why didn't you tell this before? Before I got out to work. And here it is. The slides are here already to be downloaded for now. You can scan the QR code and get a PDF download link. And my background has already been told to you. And another preamble, probably not all database management systems are mentioned here. I'm not omniscient or all-knowing that not all that should have been probably mentioned. But I will do my best to motivate you to make your mind up yourself, and will point to the sources. Actually, speaking about the sources, main parts of this talk have been taken from Akmal Chowdhury, a technical database evangelist from London. So first, the overview. I'm not explaining SQL, but I want to explain what is SQL and what it's not. Then I will talk about choosing a NoSQL store before I'm showing some database hype cycle, and then I will show modern SQL everywhere, and then I try to keep in time, if it really works out, to have enough time for discussion with you. So what is SQL not? SQL is short for Structured Query Language. The SQL standard is an ISO standard. It can be downloaded, actually, which has not been the case many years before. The latest version is SQL from the year 2019. I emphasize this because when people say SQL is relational, that's plain wrong. Modern SQL, that's not my known notion. That's also from Lukas Eder, for example, from Switzerland. Modern SQL is not only relational. I mean, SQL 92 was relational. And you remember 92? That was when they had Walkmans. That was the time when Peter Quill from the Guardians of the Galaxy, my famous notion about my students when I teach them data engineering, the Guardians of the Galaxy, Peter Quill had this kind of Walkman. That was 92, and that was relational. Only 20% of the spec pages, around over 1,000 pages, are relational. I mean, that's a measure. You can question it, but at least 80% is talking about non-relational stuff. You can look this up at another guy I like from Markus Wienand at this link. And another misconception is when talking about SQL, we mean relational databases. That's wrong too. We mean most probably multi-model databases. Now, what's multi-model databases? This picture gives an idea of, on the right-hand side of a multi-model database. It's well-established database usually, which is relational, and was from the beginning, but it has been extended to store XML, to store JSON, to store key values, to store graphs. And there is another idea which came up about 10 years ago, that larger companies need polyglot persistence because one size does not fit all. While one size does not fit all is correct, I will question this polyglot persistence too. But let's keep one step after the other. The idea of polyglot persistence with a single storage model, single model databases is that we have one software data management system for relational databases. We have one for JSON. We have one for XML configurations, for example, and you have another database, a separate one, to manage as a graph database. Now, that's what I want to say. We have the usual suspects on the relational databases, like Oracle, SQL Server, DB2, Postgres, MySQL, MariaDB, sometimes even SQLite, a very lightweight and nifty database. And these, what I mentioned just before, I call sometimes the elephants. I mean, because they are there and because they have a good memory, and they have been extended to become multi-model, not only relational. So that's something not taught, as far as I know, in lectures, the importance of multi-model databases versus single-model databases. Rule number 1 in database evaluation is OLTP or OLAP. That's short for online transactional processing, OLTP, which is mainly transactional. And on the other hand, we do have analytical databases, which is sometimes abbreviated as online analytical processing. So that are the old nouns of the two opposite goals of how your database is being used. So on one side, it's transactional when you have your core data you have which you want to store for a long time, which is in production. And on the other hand, you have analysis, real-time analysis, or offloaded data and analysis on it in data warehouses typically, which is an analytical use of a database. So just to give this rule number 1 on the decision on a database. Now, about over 10 years ago, the hype about no SQL stores came up. And mainly, this part is about how to choose the best NoSQL store. NoSQL began by saying not SQL, but it turned out to be explained as not only SQL, and that's not my definition. That's how they sometimes define themselves, and they are mostly single model databases optimized to store a specific data, which means a specific data type, which means a graph or a key value store, or another one I will enumerate just in the next slide. And the focus turned into read-optimized distributed stores, which means you wanted to scale, and you want to scale out. That was at the beginning of the of the year 2000, when the web and the cloud application came up, and the business turned into the cloud somehow. They started as a movement away from relational databases initially and away from SQL. And the focus was on from transactional to analytical, and from SQL to initially just away from SQL. But I will come back on this. And the other idea was that the database become more web and developer friendly. So, which means a shift to schema-less a storage model and data model and JSON. Now, the usual categories you read about NoSQL are 4, and I add a 5th one. The 4 ones are column store family, which means really columnar storage, or column family, which is a slightly different data structure from Cassandra. And these are, I call them stores because they don't fulfill, my higher definition of what the database management system should support. So I call it just store. I don't mean shops, I mean just storage, the storage persistence level I'm talking about. They do read optimize. They are often combined, column stores are often combined with in-memory structures, because this combination makes it really 10 times faster than the usual Volcano implementation of the relational databases of the elephants. And so the column store is a performance measure, and actually has nothing to do with the database, with the conceptual database schema. It's purely persistence and optimization focused and motivated. That's one family. And then there is another one, document stores and key value stores, which I somehow put close together because they are very doing the same thing to store documents. And I call them aggregation structures. Key value is more simpler, good for caching, for example, and document stores are as complex and as half-structured as you want. And MongoDB, for example, is a famous database management system as a document store, and Redis is a famous implementation as a key value store for caching. Then fourth, there are graph stores, which is a completely different data structure, graphs. And that includes RDF stores from the knowledge graph, a resource description framework from the guys from the knowledge management. And finally, I put all the other ones which came up into a 5th category, which is object-oriented. Still about there, but few implementations left these days. Time series, very hype. Multi-value stores, very hype, and actually no problem in the elephants. And I mean, in Postgres, you have arrays since 10 years. Every basic data type, Boolean, integer, string, you can put into an array. I mean, the problem is that the object relational mappers, the software above, does not support out of the box arrays. So that became a separate database category. And sometimes you really need to store arrays like big pictures from satellites, which are a massive data amount of data. So that's a known type, and spatial. You can look this up in dbengines.com, which is a famous homepage to look up the importance of the databases. Now the goals have been to have fewer features but high scalability. Another goal was to have a flexible data model to avoid schema pre-design for simple applications and prototypes. That's called schema-free or schema-later. The other goal was a need to have low latency, low overhead API to access data. And another was to shard databases, and the final one, to scale out. And the fifth one, to scale out on cheap hardware. And sixth, to have an increased use of analytics, which is, you remember, on the opposite side of transactional processing. Now, this is a split-up cheat sheet or decision tree on how to choose a NoSQL cloud database. Seems to be a little bit biased or incomplete because multi-model databases are missing. And in many places, it concentrates on cloud databases, but it is a good idea. It gives you a good idea, and I won't explain every single decision out of this split up into sheet. So it starts with my famous topic, data type. And then you see we have structured data types, and if you want transactions, you can, a relational storage model is recommended. And then there are the cloud offers, and then the on-premise or the local installation offers where the elephants are. I mean, I call all those the elephants. The other, you see, if you have a focus on analytics. So once again, on this analytical side where you want to read mostly, then columnar stores are 10 times about faster than the usual relational ones. And there you have the implementations and in the cloud and so on. So you see the key value, which was the third category, together with document store. You have in memory, you have white column, which is somehow a little bit different from the columnar store, from the white column. So you see Cassandra, for example, here, and the cloud database, and so on. Then you have the special case time series, and so on. So it goes on to geospatial graphs, document stores, and text search, and binary large objects. So that's to look up. I mean, I don't have to explain this. So that's in fact one helper to choose a NoSQL database. Now, what are the limitations of NoSQL databases? They lack often, they abandon transactions, which is a well-established stuff, implemented and made bulletproof 30 years ago in the elephants. Then the performance are not always as you wish to have. There are the usual benchmark sites, which I am enumerating here. They are often slower than the old-fashioned relational tabular databases, even on JSON, for example, or on graph structures. Then you can't have complex queries, often no joins and or nested joins. Then security is something lacking, and standardization. No query language standardized a little bit now these days for graphs. For example, there are now developments to have a graph spec. That are possible limitations. Now I want to discuss some premises and the goals of NoSQL, the early ones. I mean, to be schema-free and leaves you out of data modeling in beforehand. Now I want to cite some statements where they started early with MongoDB and found out that they really had a painful migration back after they found out that they had so a large lack of technical depth when you are just dealing with schema-free or schema-less databases. And another statement is over here to emphasize that it's often not a good idea. Why is it to have a schema-free approach? Because when you have the relational database, it already resolves transactions, for example, or constraints. If you have a NoSQL database system, you have to check for constraints, for referential integrity, and or domain data type, and things like this. So the schema-free and schema-later approach may lead to huge technical depth later on. I just warned you. Then there is a rise of multi-model databases and SQL in the recent years. And so we see some statements like MySQL is actually better NoSQL than most if it's used as a NoSQL engine. Or horizontally sharded MySQL that allowed infinite original scale. I mean, the idea was that the overhead and the configuration is still today, admittedly, a complex task in the elephants. So they made it not easy to shard and to scale out. That was 10 years ago, but that became better to shard and to scale out. Now the joke goes like this about NoSQL. Before it was we have no SQL. Then in the 80s, NoSQL means no SQL. And then NoSQL came up. Then they changed the abbreviation to not only SQL. And these days, it's rather no, give me SQL. Another argument which is somehow questionable is that object-oriented structures and XML need to be stored encapsulated or embedded in a database, like a document which is schema-free and you would just stuff it into the storage. And the argument was this is relational. That's object-oriented or document-oriented versus these kind of cut off in pieces relational thing, which is which seems to be weird. The answer is that if you split up your object into relational tables, you can make out of the structure this or this or this object. And that was the idea of the storage layer. Now, the database hype cycle. A quick market analysis on NoSQL turns out that these days about 2% of the size is only covered by the NoSQL databases. I mean, the amount of purely relational databases decreases, according to my observation, 1% per year from 80% 8 years ago to 72% this year. So it is shrinking, but only marginally. And on the other hand, there is an explanation. So for example, MongoDB's market capital is about many billions. The revenue is about less a billion, which means they are overvalued of 20 times. which is a huge gap. I'm not an economist, but just to compare, Apple is overvalued only 6 times in the market. So there is a chance that, and I just want to say it's all about marketing. So I'm just showing us a rough figure of the market of metaverse, which seems to explode next 10 years. I doubt it, but I still believe in 3D and all this immersive augmented mixed reality. But still, the same happened for databases. So since the early 90s, there have been several waves of database technologies, like object-oriented and so on, and they just stirred up a large hype. The great debate. About every 10 years ago, there is a great debate on the future of no SQL category. So it goes like this. There are the R people, the relational people, like me, and there are the refuseniks. The great debate goes like this. The refuseniks say, you relational people with your flat tables and silly, boring SQL, you are so unhip. You simply cannot deal the problem with graph, for example. The R people say, you make some good points, like graph structures, but there is a large amount of money invested already in building scalable, efficient, and reliable database management products, and no one is going to drop that all on the floor. We plan to incorporate the best of what you just mentioned, and that's what happened. So actually, more or less, you see, 25 years ago, object-oriented, gone on the market. Native XML databases, gone. 10 years ago, no SQL and JSON. And what happened? JSON has been incorporated into the multi-model databases. And that's what we are these days. We do have some kind of all those that are NoSQL, at least most of them, incorporated into the elephants. So much marketing going on in IT, especially for startup databases. There are nice new kits on the place, but they are not major as they would want to see. That's all what I want to say. So I made a search on Google Trends about SQL versus NoSQL versus Java, and the red flat line is NoSQL. Then another interesting stuff is multi-model database management system on the hype cycle of the Gartner hype cycle is now on the maturation phase. And we do have time series, which is interesting, for example, and data lakes and things like this. So quite some interesting stuff going on, but it's on the maturation phase here. So the conclusion is relational database systems remain the dominant database technology because a single product is there as matured. That's what I want to say here. Now, when choosing, that's my recommendation. When choosing a database, don't be a lemming. You know, don't be a lemming just because it's hip to choose a NoSQL database these days. Think about identify technology trends without overstating the marketing noise. Know the fundamentals and the computer tools. Choose the right product for the job. Next type, which is going on these days, is cloud databases. But I don't have time for this because I wanted to say something about modern SQL everywhere. What do I mean by modern SQL? Modern SQL is SQL beyond relational. It's data types and operations like Boolean. I mean, Oracle had an update these days to incorporate Boolean. Boolean was around 30 years. At least they did it. But I also mean arrays, user-defined data types, which are possible in the database. The JSON type, including JSON path, you have a query language inside the data type, like XML path. Very interesting stuff. Full text search is in the database, common table expressions, including recursion. So one of the drawbacks of 92 SQL was you can't have recursion, which you need to query a tree. Window functions for reports, that's modern SQL, or the graph type, sometimes as plugin, like in Postgres, when you extend Postgres, which is open source, you can't call the thing Postgres. It's like an MIT open source, but if you commercialize the stuff, you need to rename it. So under the hood, sometimes, very often, there's Postgres because it's somehow hackable. And modern and new SQL are beyond no SQL, what I want to say. So the new challenges are near real-time analytics, transactional support, preserving SQL, and preserving the investments in your skills, knowing SQL probably, in the tools and the data. The tools like backup tools or schema, database schema, change management. Database schemas, change management is not often taught, unfortunately, in universities. How to keep up, like in a version control repository with the schema changes. That's a very important basic knowledge. Now, I have a few minutes to just skim over unexpected application of SQL. I start with, so 5. That's what's now coming. SQL in NoSQL stores means there are more SQL projects in NoSQL databases trying to offer a SQL API than SQL databases. Then that's what they say in this talk, the unreasonable effectiveness of SQL. And almost every popular NoSQL database have a variation of SQL, like Couchbase, Cassandra, Elasticsearch, and even MongoDB, if you look closer. Then, second, in business intelligence, Tableau is a unicorn startup, the market leader in business intelligence dashboards, simply. Or Microsoft Power BI, they have just views under the hood. So you have to write a view for the report, a SQL view, I mean. Excel has Power Query, also with a weird history, but so you can do big data even in Excel by extracting data. Google Sheets has a where clause, like here, some select clause. Then there is the open source superset, which I'm using here in the dashboard of enhancing OpenStreetMap data in the leaderboard. And another nifty thing is dataset with a plugin where the output of a SQL statement is just a graph directly. I mean, a graph like this. Very nifty implementation, this data set. Third, SQL in data integration. 5 years ago, when the data warehouses have been superseded by the famous data integration tools, data lake tools, then it came up a software called dbt, and dbt looks like this. So the goal is to have sources, and over there you want to aggregate and extract and load them into a database and transform it into the target structure to be analyzed in order to make a dashboard or some decisions. So dbt took SQL and added templates on it, so that you can break up a large SQL statement into pieces which become reusable and which become versionable. And that's the thing. I mean, that's one of the greatest things in data integration around this kind of tool. Then, fourth, SQL in machine learning. We do have two interesting topics at the VIScon: security and, of course, machine learning. And what the heck? SQL in machine learning. The power of SQL is there, And why not doing training and prediction where the data resides? Inside the database. And that was this notion of another guy, enter PostgreSQL. PostgreSQL is another tool, not from me, which is an extension to a plugin to Postgres, because Postgres is so nicely hackable. And it's an end-to-end machine learning system using only SQL with an open source extension. It has visualizations, hyperparameter search, it is open source, and it goes like this. It adds this package PGML, and you have a method, a function, train. You give the training model a name. You choose algorithm, like regression. You choose the database source, which is digits. This is about recognition of handwritten digits. I mean, one of the basic examples of machine learning in image recognition. You say, you give the target feature, and you identify the specific algorithm, and because it has each XGBoost or scikit-learn under the hood, and then you train, you wait and see what comes out. And when you trained it, you have a select statement with the same model you trained before, with the target you want to predict, and how you get the result set of the recognized digits. That's machine learning in the database. And it's extendable because it's open source. Finally, the software, SQL in software development, that's a huge topic on itself, but only one slide on this. Lukas Eder said, SQL is the only ever successful mainstream and general purpose fourth generation language. You won't imagine how the SQL database will outperform any handwritten data retrieval algorithm. I mean, it's about extraction and analytics. Just looking at the analytics, for example. So it's the best language for business logic. Just one example. When you have an elephant and you give him an SQL statement, whatever complex it is, it will try to optimize the statement before it's being executed. You know, the statement is being translated into a syntax tree and reorganized in order to optimize the statement. So it decides which is the best one to, for example, if you have a remote table and you have a local table, we have a large table and a small one, you try to optimize the fetching time and the data processed, and you organize the statement. When was it last time when you wrote Java code where you thought about another execution plan of your Java code? I doubt you ever changed your implementation and offered two implementation of the same retrieval. So that's the argument how sometimes databases you have one pager of SQL which is shorter and faster. That's it from my side. So I hope there is some time for discussions or questions.
Yes, thank you so much. We do have some time for a few questions. Is there any questions in the room?
Is there any reason to use NoSQL instead of normal SQL?
Any reason?
Yeah.
Of course. Of course. When I recently advised a thread database where 20,000 threads come in a day, and you have to store the incident, which have constantly changing information attached to it, you know, the email infringements or things like this. And then I recommended, because it's such an undefined domain, how to describe an incident of possible infringement mail or money transaction, then so if it's really an unstructured and foreseeable changing domain model, then I would recommend a document store, but which may be MongoDB, but it could be also an elephant, because JSON is so well treated in the elephants these days. Sometimes I even recommend SQLite, which is an in-process database. If you have a single seat application where you don't have to share your stored data, I even recommend SQLite, which is a very small database you can easier start and handle with. And so I recommend a document type, and then I leave it open if you choose MongoDB or Postgres or SQL Server or something. But the decision is it's document type to me. Another example is we had a network analysis, computer network packets analysis, where you have all the packets moving locked, which moved around. So you have a graph of degree of 4 levels. And I found out in my benchmarks that up to 3 hops, I mean, graph and node hops, the relational approach is faster. But when you go beyond the graph, so you have a graph type, I implemented relational or in a graph store. So if it's more than 3. A foreseeable more than 3 queried nodes, Neo4j, for example, was faster. I did not yet check the Postgres extension, the AGE, which has a graph, a query language, Cypher, open Cypher or something, which could be also a solution of an elephant. But multimodal is for me also NoSQL. So my decision is like this. Yeah.
Great. I think we have time for one more question.
Sharding is also easier still in MongoDB, I mean, out of the box.
Hi, thanks for your interesting talk. What are your thoughts about getting predictable performance in Postgres or other elephant databases? A predictable performance. So the query optimizer is also one culprit of these elephants, I think, because you don't know what the database is going to do internally, and thus the performance might differ from time to time, right?
First of all, the planner tries to adapt, but it can be worst case become slow. I mean, the planner tries to adapt, especially this case when the storage grows. But you can have unpredicted slow performance. And guess what Google did when they offered Postgres in the cloud? The first extension they made on their own to my yes. What did they do? They offered an automated optimizer recommender. In order to identify slow queries and to suggest indexes or something. And if this is what you ask.
Yeah, that to some extent answers the question. But I mean, on top of that, we also have stuff like logs where we don't know whether a log is available at that point in time. So like the query might be fast in general, but then a log is held on a specific row, which makes a query slow for a specific amount of time. How would you deal with that problem?
I don't know what you mean. I remember a debate when Postgres has been kicked out because of write lock problem, and
like that is the case, right?
My answer is the same.
Editing.
Is this
table.
what you mean?
Yeah. I mean that's a problem.
So my
right?
answer is they fixed it the next release. I mean, that's the usual answer of every vendor. So they fixed that in the next release of Postgres. This kind of lock overload when you have many writes.
Okay, so you think you could just solve these problems by extending the existing systems as well, where like logs slow down queries?
Yeah, yeah. I mean, I don't know what you really want to come out because the optimization in RDF stores was no issue. 6 years ago, RDF stores had no single knob to do any optimization. And now you are challenging the elephants, which have 20 years of optimization.
It's optimization done by the database management system, which you can't really interact with, right? It's not like there might be information that the developer has, but the database management system doesn't have, right?
Yeah, yeah.
When I'm like using Redis, I always know what Redis is doing. I always know that a specific query will take a certain amount of time because I know that internally it will do a certain thing.
And so you mean you as a developer can give hints that so that the database knows because and you want to help the database with a hint?
Like bringing more information from like more knowledge from the developer into the query management system.
That's a good idea actually. And Postgres Pro, for example, and Oracle have these implementation hints. I mean query hints.
Yeah. Okay. Thanks.
If this is what you mean, that if you really know what you do, I'm in favor of this query hints. Yes.
So I don't want to interrupt the discussion. It's just lunchtime now. People that want to get lunch, it's just right outside of the door, I think. You can go, but you can continue discussing. So if you want to talk about it more, and I think you have a question too, we can continue this discussion, just so that no one feels hungry and empty. So please feel free to continue it, if that's all right. So please give it up for Professor Keller. I think you did a very good job showing us something that we did not learn in the lecture, because we never learn anything about IT marketing and what it does to the solutions that we choose. So please give it up for Professor Keller. Or maybe you want to go.
No, well, it was more.